The American meteorologist Edward Norton, Lorenz, was checking a weather simulation on his supercomputer in 1961. Just to be sure, he decided to manually enter the values and run the program again. When he looked at the results, the data didn't match at all. What a mess.
Have you tried rebooting your router?
He had entered the values correctly, except for 3 insignificant decimal places he hadn't included. How could that be? Those 3 tiny decimals are like a speck of dust in a building. How could that possibly affect the whole thing? It's as if the flap of a butterfly's wings in Brazil could produce a tornado in Texas. And that's how the term was coined. The butterfly effect. The butterfly effect does not mean, and this is very important, that anything can cause anything. It means that in certain nonlinear dynamical systems, small differences in the initial state can be amplified exponentially and become impossible to predict with precision. It is the ultimate expression of chaos theory.
The essence of chaos.
You see, not many people know that in 1812 in France, an all-powerful demon suddenly appeared. One capable of knowing the past, present, and future alike. In the mind of Pierre-Simon Laplace, of course. With this allegory, Laplace wanted to explain that if an all-knowing being could know the initial states of all the atoms in the universe, it could calculate with precision where they would be at any future moment, knowing the future just as it knows the past. This is classical determinism, and it makes sense. If the universe operates according to the clear and objective laws of physics, and we take a screenshot of the universe right after the Big Bang and analyze it particle by particle, we should be able to determine that because of the strong, weak, and electromagnetic forces, they will move this way, and over time, massive clusters, due to gravity, will move that way. We could predict not only the future configuration of galaxies and planets, but the exact day
Chester Copperpipe
will be crushed by a rock while searching for treasure. But in reality, if we start with this, applying the laws of gravity, we can easily predict its motion and where it will be in 10 million years. But something strange happens if what we have is this small difference. Now this body affects that one, and that one affects the previous one already influenced by this one's gravity. And the more time passes, those small differences evolve exponentially, and we end up with a completely chaotic and unpredictable mess. This is called the three-body problem. In 1889, King Oscar II of Sweden and Norway wanted to celebrate his 60th birthday, and since he'd due as king, he decided to throw the wild, outrageous party everyone dreams of. And established a mathematics competition. One of the problems to be solved was the n-body problem. The French mathematician Henri Poincaré submitted his proposal, focusing for simplicity on just 3 bodies, and won the contest.
Yay!
In his study, he solved the problem by proving that it could not be solved. The evolution of such a system is extremely chaotic, in the sense that a small perturbation in the initial state, for example, a tiny variation in the initial position of a body, could eventually lead to a radically different state. Can you imagine a small action, like, let's say, subscribing to this channel, could have unpredictable consequences? It's fascinating to realize that everything starts from simple, objective mathematical laws, yet as it evolves, it inevitably ends in chaos. And if that happens in systems governed by simple equations, imagine something like the economy. When you watch a video of a crypto bro or a trading guru predicting the evolution of the markets, where you also have to factor in human behavior. On June 14, 2021, Cristiano Ronaldo, the football player, yes, football, during a press conference asked for water instead of the Coca-Cola placed in front of him. That same day, Coca-Cola's market capitalization dropped by $4 billion. Analysts said it was normal. Social media went wild. The press highlighted Ronaldo's gesture. Thousands of factors influencing one another. But relax. The financial guru will make you millions predicting every single detail. Hey, just Taylor Swift deciding to tour across the U.S. in a given year affects the country's GDP. But it gets even stranger. In 1987, Per Bach Chao Tang and Kurt Wiesenfeld proposed the notion of self-organized criticality. In their example, imagine a pile of sand, say in an hourglass. Gradually, the sand forms a pile whose slope, increasing slightly, brings the pile to a critical state, where a single additional grain can trigger a small or large avalanche, potentially collapsing the entire pile. At a local level, one single grain can cause a global disaster, but the whole system naturally returns to that critical state, again to a point right on the edge of chaos. Hence, self-organized, because it returns to that state on its own, without external intelligence or force. Doesn't that sound crazy? Many natural systems self-organize to remain in a state at the edge of chaos, avoiding absolute stability and thereby allowing progress and change. Our own brain regulates itself at that threshold, neither too ordered with limited activity, nor too chaotic like during an epileptic seizure, allowing large-scale information transmission and high responsiveness to stimuli. This creates a perfect fine line that optimizes cognition. And how do we go from something simple to something extraordinarily complex, starting from basic instructions and without external regulation? Through self-similarity. They're called fractals, defined as a geometric object in which the same structure, fragmented or seemingly irregular, repeats at different scales and sizes. The term was proposed by the mathematician Benoit Mandelbrot in 1975. And do you know where we see them? Everywhere. Have you seen Romanesco broccoli, leaves, tree branches, rivers, lightning? No two snowflakes are alike. Clouds, snail shells, octopus tentacles. How beautiful is a peacock? Honeycombs, bronchi, our eyes, our circulatory system, and of course our neural networks. Mandelbrot once said, "Clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth." Because even if they seem simple, when you look closely, the patterns of nature are exquisitely complex. By the way, did you know there's a phobia of fractals? It's a variant of trypophobia, an irrational fear of small, clustered holes. We're crazy. Although, to be fair, they are a little creepy, aren't they? With these patterns, fascinating things happen. Have you seen the mega structures termites build? From the outside, they might look like a pile of mud and slime, but inside, they're mind-blowing. They're built facing north to receive the midday sun, with an intricate tunnel system that promotes ventilation, delivers oxygen to the lower levels, expels CO2, and maintains a stable temperature. We've even copied them. The Eastgate Center in Harare, Zimbabwe, was built based on termite mounds and doesn't need air conditioning or external ventilation systems. These animal colonies function as self-regulated systems. In schools of fish or bird migrations, there's no leader guiding the rest. There's no termite architect arguing with the construction manager about foundation quality. They follow a kind of collective awareness. All of this is known as the physics of complexity, which states that the whole is more than the sum of its parts. We try to understand things by knowing everything about the parts that compose them, but they influence one another, leading to unpredictable chaos. The climate, our minds, the economy, and ecosystems operate with thousands of factors at the edge of chaos, self-regulating without an external force. Maybe, in the end, the universe itself is an immensely complex system at the edge of chaos, self-regulating. where all its parts influence one another, and it can only be understood as a whole, and not just by the sum of its parts.
The essence of chaos.